In this problem, I've got two disks, one of 2 kilograms that has an initial velocity of 5 meters per second, and one of 4 kilograms, which has a velocity of 2 meters per second in the opposite direction. Okay, they're going to collide. Their coefficient of restitution is 0.4. Let's figure out our velocities after the collision. So there are two equations that will apply here. Conservation of momentum for the particles combined, and then that coefficient of restitution equation that I have. So conservation of momentum says my initial momentum is equal to my final momentum. So for A, that's going to be, the mass is 2 kilograms times 5 meters per second. For block B, it has a mass of 4 kilograms and a velocity of -2, again going in the opposite direction, meters per second. So that's my initial momentum. My final momentum is basically 2 times VA2 plus 4 times VB2. So again, my unknowns are my final velocities, but I know my initial momentum and the relation to the final momentum. The other thing that applies is my coefficient of restitution, which is essentially VB2 minus VA2 over VA1 minus VB1. So I know my coefficient of restitution is 0.4. I know my initial velocities here, okay? Remembering that the velocity of B is in the negative direction, so it's actually 5 minus a -2, so be careful with your signs here, okay? So I have two equations now. I have my conservation of momentum equation, and I have my coefficient of restitution equation, okay? And two unknowns, VA2 and VB2. I can simply solve those to find the velocity of A and B at the end. Again, the negative answer for VA2 means that VA actually shifts directions and goes to the left, and VB2 goes towards the right because now I get a positive. Again, my positive is to the right, negative is to the left.